Alright, let's talk about this photo. It's Blackpool Tower in the foreground, snow-capped mountains looming behind it. SciManDan used this in a presentation. A guy named Ranty used it and famously left the flat earth community over it. It circulates like clockwork, and when it does, the caption is, "This photo proves the globe." So I decided to actually test that claim. Not argue with it, test it. And like many of my investigations, I didn't end up where I expected to. The claim is Blackpool Tower, 158 meters tall, sits about 19 kilometers from the observer. Behind it, Dow Crag in the Lake District, 778 meters. It sits 81 kilometers from the observer. 5 times taller, but over 4 times further away. SciManDan's argument was to do the math, and the mountain should tower over the tower in the frame if the earth is flat. But it doesn't. Therefore, curvature is hiding its base. Therefore, earth is a globe. My first instinct was parallax, because that is a well-documented phenomena. I made a video showing that a closer, shorter object can appear taller than a further, taller object, and that lifting up the observer height changes the relationship between the two objects. It's basic angular geometry, and I was confident. Then I did the arctan math, and the math that Dan was talking about was actually correct, but based on the inputs. But if the inputs are flawed, then the output will be flawed, and the conclusion will be wrong, even if the math was done precisely. SciManDan didn't argue with my video. He just asked me if I know the angular size formula, the real one, arctan of height over distance calculated separately for the top and the base of each object. He said the mountain should still appear taller on a flat earth, and it doesn't, so the flat earth is done. That's when I realized something. I'd been arguing the mechanism. Yes, parallax is real, eye height matters, but I hadn't actually run this calculation on this specific photo with the real numbers. So I had to do it. I used the real distances, the real heights, but naive assumption. Both objects' bases sit around sea level. The tower is about 0.49 degrees of angular height. The mountain about 0.55 degrees. The math said the mountain should look bigger or taller, not smaller. That matched what SciManDan was saying. My gut reaction about parallax was actually wrong, or at least incomplete. And the correct move was to say so and keep on digging, not to defend the position I started with. Although parallax is a real thing, the math is the math. But the actual photo, the mountain doesn't look bigger. It looks smaller or shorter. 60 pixels tall against the tower's 82. That's a real measurable gap between prediction and reality. Something was missing from the naive calculation, and I had to figure it out. So what's missing? If you look at the actual photo, there's a whole town, basically a skyline of buildings in the way. Blackpool's seafront. Buildings, a roller coaster, a chimney, a Ferris wheel, sitting directly in front of where the mountain's base would be. Which means whoever measured 60 pixels wasn't measuring the mountain's true height. They were measuring peak to wherever Blackpool's skyline happens to block the view. Nobody, not SciManDan, not any AI overviews, not anybody in any of their video that I watched, had actually said what the cutoff point corresponds to in real elevation. And the sensitivity here is brutal. I calculated that the gap between prediction and reality works out to about 0.21 degrees, less than half the angular width of a full moon. That's the entire disagreement. A number that small, sitting on top of an unverified obstruction line. It means neither side had actually proven anything yet. So instead of arguing the mechanism further, I decided to just test the actual competing model directly. What does pure curvature predict? with zero refraction, no fudging. I ran it, and the real horizon distance for an 8-meter camera height, which is about 24 feet. Real hidden height formula, the tower loses about 5.5 meters to curvature. Nothing, basically invisible. The mountain loses about 400 meters of its base. That's about 1,200 feet. The result, on a pure curved earth geometry, the mountain should appear at just over half the height of the tower, about 56% of the height of the tower. The actual photo shows the mountain at roughly 73 to 80% of the tower's height, and that calculation is based on counting the pixels, which somebody did. So now I had 3 numbers that didn't agree with each other. Flat predicts the mountain looks bigger than the tower. Pure curved geometry predicts it looks about half the size. The real photo sits in between both predictions, noticeably taller than pure curvature says it should be. So at this point, I did some research to find an explanation. An AI overview said atmospheric refraction, cold air over relatively warmer seawater. I found creates an inverted temperature gradient. The exact setup that produces looming, enhanced refraction, the kind of thing that could lift that missing 20-some% right into place for the globe win. That would have closed the gap, so I checked it. I looked up the time and date of the photo. I pulled the actual verified weather record for Blackpool Airport on January 24th, 2021. The real day this photo was taken. Sub-freezing air all day. Cold, yes. But then I checked the actual meteorology of what cold air over warmer water actually does. And it's the opposite of what the AI had claimed when they invoked refraction because they're protecting the globe model. The setup does not create a stable inversion. It creates instability, warm air rising off the water into the cold air above it. That's not the condition that produces looming. If anything, it leans toward the opposite effect. So the one mechanism that could have closed the gap cleanly, checked against real data, didn't hold up. So refraction cannot be invoked here as an ad hoc rescue device to save the model. So where does that leave us? Not with a victory for either side, with a specific, narrow, honest problem. Pure flat geometry doesn't match the photo perfectly. Pure curved geometry doesn't match the photo either. It undershoots by a real measurable margin. Refraction, the standard explanation people reach for to patch that gap, doesn't hold up once you check the actual conditions of the weather for that specific day. Which means the only way left to make the curved Earth prediction match this specific photo is if the camera was elevated somewhere around 150 to 200 feet above sea level, high enough to shift the horizon and reveal more of the mountain's base. And there's no documented platform, hill, or structure of that height anywhere along that stretch of coast. Every account of how this photo was taken describes a guy walking the beach with a camera. So where have I landed? Not where I started. This photo, the one that's been used for years to settle the argument in one direction, doesn't actually settle anything. Not because I proved the Earth is flat, because nobody on either side had done the verification the claim actually required as far as I was able to find. And once you do it, actually do it, not assert it, the case collapses into a specific open question that neither side has answered yet. But if they have, let me know, send it to me. I'd like to see it. That's the whole point of holding a claim to a falsifiable standard. Sometimes it doesn't go where you expected. This one didn't go where either of us expected. And there is a significant importance here that a guy who was a flat earther named Ranty took a photo to attempt to prove that the Earth is not a globe. But then he was attacked by experts on the globe side who did some calculations, and you can check those calculations and they're actually correct. But they were using incorrect input to force their desired output. I'm not saying they did it intentionally. Nobody's perfect. People make mistakes. But Ranty, the actual photographer and flat earther here, publicly denounced the flat earth based on those calculations. And come to find out, the calculations had incorrect inputs because the base of the mountain was blocked by the promenade of the city line below the tower. They actually tricked him into denouncing the flat earth. So maybe he wasn't even a flat earther to begin with. It wouldn't surprise me if he was sent by the globe to pose as a flat earther in order to make an observation to prove the earth flat, in which he gets allegedly proven wrong by experts and then flips back to the globe. I mean, I'm not saying that's what's happening here, but I wouldn't be surprised. I mean, that's a good play on their side because they're the ones that are pushing the narrative. We're the ones looking for the truth. It goes to a funny old argument that flat earthers don't understand science. But if they convert back to the globe, suddenly everyone on the globe side agrees with them now. And they're smart again. So suddenly they understand science now. And I don't like that at all. If somebody believes in aliens, that has nothing to do with how intelligent they are. Someone very, very intelligent can believe something that is not true. Somebody who is not intelligent at all can believe something that is true. So believing something is true or false cannot possibly be indicative of your intelligence. Your intelligence will speak for itself. You know, the smartest people in the world will be wrong sometimes. The least intelligent people in the world will be right sometimes. And that's one of the main problems I have with this debate. We're just talking about data. We're talking about data, observations. There's no reason we can't have a conversation. If someone's going to disagree with everything I say just because the conclusion that I've drawn based on my research is that the Earth is not a globe, now they're going to disagree with everything I say because they don't want to shatter their worldview and they want to protect it, that's disingenuous. Completely disingenuous. So, do your own research, draw your conclusions, but always listen to people. If somebody has a differing opinion from you, that's important. It's important to hear opinions that are different than your own and compare them. Of course, I want to say, hey, the tower looks taller than the mountain because the camera's lower, and if you lift the camera up, the mountain will rise up because it's further away, and then the mountain will appear taller than the tower. But I did the math, and that's not exactly what's happening. This observation is based on the height of the observer and what you should see. The real problem in this investigation is this right here, this promenade. This promenade is blocking the bottom of the mountains. So when they count 60 pixels up for the mountain and they count 82 pixels for the tower, now the mountain is covering 75% of the tower. But when it comes to the curvature of the Earth and predicting how much hidden height there should be, you got to remember that you have to use height above sea level. When you're talking about just the angular size and perspective geometry and the angular size of the object in the frame, you just take the base measurement, peak measurement, and you count the pixels, and you figure out the distance, and you can figure out how large it is and see if it matches the predictions of what you expect to see and what you do see. But when we're talking about the curvature of the Earth, which on this photo here, I don't see it. I don't see any curvature. Even though the curvature of the Earth says that this tower should be hiding below 19 feet of curvature, when you zoom in, you can literally see the base. You can see its base. So how is it hiding behind 19 feet of curvature? And if we look closer, this is supposed to be dropped behind 19 feet of curvature, but look, you can literally see the shoreline. You can see everything going across, and then you see the shoreline, and you can see the base of the tower, and then it's going up. So the curvature is supposed to be hiding 19 feet. Where's the 19 feet being hidden? You can literally see the beach. So when I do the curvature calculation to see what's expected to happen, how the mountain is supposed to only be 55% of the height of the tower based on the Earth's curvature geometry, I have to account for the fact that this tower is supposed to be hidden behind 19 feet of curvature because it's following one curved line So I can't keep this one just because I don't see the curvature and nothing is hidden. I can't just do the math and keep this on a flat plane while I put the mountain on a curve. That's disingenuous, and I'm not going to do that. I put them both on a curved surface, and I did the calculation to figure out where each one would appear in the frame and at what height, what percentage of the tower the mountain will be at. So the mountain's supposed to be at about 55% of the height of the tower, but we're going down to sea level. So I had to add the height of the tower with the height of the promenade, which is about 36 feet. So now 55% is not even just half, it's down here. So if the earth was curved, the mountain would literally be down here. And you can't invoke refraction because I've already looked up the weather data. And in the weather data, the refraction is never zero, but it's as close to zero as you can get for that specific day. It's a day with technically virtually almost no refraction. So what's lifting the mountain up to here? And if you look closely, it's not a mirage. We're looking at the actual cliff. It's not distorted. It's not refraction. It's just because the earth is flat. So the observer is looking up. And right here is 19 miles away. The mountain is way further, like 80 miles away. So because the mountain's 80 miles away, it's going to go to perspective convergence, is going to bring it down to the vanishing point. That's what I think is happening, because the mountain, according to the flat plane, is supposed to be 107% of the height of the tower. We still need more answers, but if the earth was curved, the mountain would be down here, and there's no explanation for why it's here. But on a flat earth, the mountain's supposed to be maybe up here, 107% of the height of the tower, but it's down here. But my thinking is that that's perspective convergence, and it's converging towards the vanishing point. And because of that, and because it's so far away, it's gonna appear a little bit shorter. But if anyone has anything they want to add, go ahead, add it. Let's talk about it. You know, as a truther, I'm not afraid of any conversation at all, because I just want to get to the truth. I am biased to the truth. If NASA took me up into outer space and I went to the moon and I saw the globe Earth, I'd come back and I'd say the Earth is a globe. I have nothing to gain from the Earth being flat at all. You know, like, the last thing I want to do is for people to be like, oh, that guy's crazy. I don't even take him seriously because he thinks the Earth is flat. But at the same time, I have to be honest. And I've done research and investigation that's led me to those conclusions based on data, based on observations, you know, based on the fact that this mountain is supposed to be down here, not up here. What gets it up here? Why is this up higher? Why is the ground going up, ramping up? Because the sky ramps down, the ground ramps up. That's perspective convergence. And over long distances, you're going to get some optical effects like this here, where maybe the mountain looks a little bit shorter, and maybe there was a couple errors in the calculations in terms of, you know, how tall this is or how tall this is, or because it's ramping up, maybe it just appears a little bit higher because it's so far away. I mean, there's help me out here, you know? Let's get the data. Let's figure it all out. Let's figure out exactly why the tower is a little bit taller than the mountain on a flat plane. Because I feel like the fact that there's no refraction on this day and the mountain's supposed to be down here proves that the earth is not curved. Because what's getting the mountain up here? Because anything that's higher than you is going to converge down. This thing has gone up. You know, at least on a flat plane, it's just a little lower than it's expected to be. But it's not higher than it's expected to be, because that wouldn't make sense, because it's above your line of sight, which means it would converge towards your vanishing point, which is down towards your line of sight. And that's, you know, basically, to me, that's my smoking gun. So, holla back, fire back, let me know, Dusty Truth.